Hello everyone, in this video, we will build a simple chatroom application using WebSocket server and client in .NET with C#. WebSocket is a protocol that enables seamless communication between clients and servers over a single, long-lived connection, unlike traditional web communication methods like HTTP, which follows a request-response model. WebSockets introduce a full duplex communication channel. This means that both the client and server can send and receive data simultaneously, allowing for instant updates and real-time interaction. WebSockets are commonly used in scenarios requiring real-time data updates. Examples of such situations include a multiplayer game's lobby chat, real-time notifications, stock market data feeds, and live collaboration tools. These applications necessitate instantaneous communication and data exchange, something that WebSockets adeptly provides. Let's start with creating a WebSocket server. First, open Visual Studio and create a new ASP.NET Core project from the template. Pick the ASP.NET Core empty template with the C# as the language. Enter your project name, location, and solution name. I will use Chatroom WS as the project and solution name for our WebSocket server. I'm going to use the latest .NET 8 and leave everything else unmodified. To use WebSocket in our project, we call the useWebSockets function on our web application instance. Then we need to map an endpoint to be used for our WebSocket server. We will do this by using the app.map method with our root and context, which we will use for handling WebSocket. Here we will use WS as the WebSocket root. Inside the context, we will configure the endpoint to accept only WebSocket connections by implementing a check of context.websockets.as WebSocketRequest. Then set the status code to badRequest 400 if it is not a WebSocket request. After checking the connection as a WebSocket request, we can define the current connection instance. To send a message, we can use sendAsync method on our WebSocket connection instance. The sendAsync method accepts arraysegment bytes, WebSocket message type enum, bool end of message, and cancellation token as its parameter. To send a text to the client, we need to convert it into a byte array and create an arraysegment byte with it. Here is an example of how you would send a simple hello world message to all clients connected to the WebSocket server. Now let's make our WebSocket server return the current time in HHMMSS format every 1 second to the client. We can do this by wrapping the logic that we use to send messages inside a while true loop and using thread.sleep1000 to implement the 1 second delay. We will also check to only send the message when the WebSocket state is open and break the loop if the state is closed or aborted. Voila, our WebSocket server is done. Now to check it, we need a WebSocket client. Let's create a WebSocket client to listen to our WebSocket server. First, open Visual Studio and create a C#.NET console app. Enter your project name, location, and solution name. I will use Chatroom client as the project and solution name for our WebSocket client. To create a WebSocket client, we can use the client WebSocket from system.net.websockets. To connect with a WebSocket server, we can use the connect-to-sync method with the URL and cancellation token. We can get the URL of the WebSocket server by going to Launch Properties of WebSocket Server Solution. Now let's create a task to receive a message from the server while the connection is alive. To receive the message, we can use the receiveAsync method on our WebSocket client instance. The receiveAsync method accepts array segment of byte and cancellation token. To receive a message, we need to create a new byte array as a buffer which we will use to create the array segment of byte. For cancellation token, we will use cancellation token.none. Remember that the result is still in byte array to display it as string. We need to encode it first. We can do it by using the encoding.utf8.getString method. Lastly, we need to check if the connection is not closed before processing the result. We can do this by checking if the message type is not close. Now run our WebSocket server and then client. If it worked, then our client should be displaying the current time every 1 second. Voila, we can create a WebSocket server which can send a message and a client that can receive the messages. Let's implement a simple Chatroom application with WebSockets by modifying our previous code. To keep track of multiple WebSocket connections in the WebSocket server, we can store the WebSocket connection instance in a list. To broadcast a message to every client, we can create a function that calls the sendAsync method with every WebSocket instance that is open in a list. To emulate a chat room, we will add a username for the connected client, which is fetched via the request parameter. We will also broadcast whenever a client is connected. Now, let's handle the process of receiving messages. Similar to the client side, we can call the receiveAsync method with a buffer while the socket state is open. Let's wrap this logic into a function receiveMessage. Then call our receiveMessage function inside our WS handling code. Now to broadcast the received message to other connected clients, we need to modify our receiveMessage function. Let's add an delegate which takes WebSocket result and returns byte array called handleMessage in our receiveMessage function parameter. Call the handleMessage delegate by passing the result of receiveAsync and buffer. Then modify the original receiveMessage call to pass a lambda function containing the delegate. Inside the lambda function, we will broadcast the received text message from a client to every client. We can do this by calling our previous broadcast function if the results message type is text. What if we want to keep track of clients closing the connection and broadcasting it to everyone? First, we need to check if the message type is close, or if the socket state is aborted. Then remove the closed WebSocket connection instance from our list. Then we will call the broadcast method and closeAsync method to close the connection gracefully. We are done with our WebSocket server. Now let's modify our WebSocket client to handle sending messages to the server. First, let's add username input which will be used in the chat room. Create a task to handle sending the message to the WebSocket server. Here we will read the input from user and send it by calling sendAsync on the client WebSocket instance. We will add a check to exit the chat room with exit text input. We have both receive and message tasks running asynchronously. Finally, handle the client's exit by sending closeAsync whenever one of the threads is finished. Then await until all thread is finished to close the program. Our simple Chatroom application built with WebSocket is now done. However, before running this and testing this application, we need to do a few corrections. First, we need to send the name as query parameter while making a connection. Then, we need to increase the buffer size while encoding in the receive task. As we had a buffer size of 1024 on the server side, we can have equivalent to that or slightly greater, so that we can encode the entire message at once. Now, let's start the WebSocket server and connect a few WebSocket client to it. I'm running the clients from the executable, so that I can run multiple clients. Let's join the chat room from the first client. We have now joined the chat room, and it display the total count of connected users as 1. Now let's join the chat room from the second client. We have now joined the chat room, and it display the total count of connected users has gone up to 2 now. Now we can see that message sent by one client is received by another client. Great! We now have a simple chatroom application in .NET using WebSockets. If you like the video, please like, share and subscribe. Thank you.